Okay, so for today, what we'll be doing is combining Pytorch with OpenCV. So to give you a demonstration, we'll be taking our Python side onto our C++ side. This will be somewhat like our previous video, but the only difference is instead of doing this in Python, this is on C++. So I've already created a torch script model. You could watch the previous lesson on how to do that, and basically the model's already made. So you can see it's predicting the lanes. It's a little blurry, but we can see what the model's trying to do essentially, right? So let me close this down. And let's go back to what we need. So you're going to need libtorch, obviously, and you should already have that. And you're going to need to have OpenCV installed. So depending, if you have Linux, you can follow this. If you have Mac OS, you're going to have to find, or Windows, or whatever, those two that you have, you're going to have to find another way. But if you have Linux, you can just follow this, and you should be able to install OpenCV perfectly fine. I do have a repository with the CMake file, but I'll show you that right now as well. So if I do go into there, you can see basically everything that I have to install OpenCV. So you can just follow this. I'll keep this in the GitHub repository. You can just copy and paste it. I have a link to how to get Pytorch and OpenCV working together. So I'll leave a link to this file. Another thing you're going to need is basically, if you're going to follow this, you're gonna need a video. So you can see right here, I do have the model. Obviously, I told you that I already have the torch script model, and I have a driving video right here, which basically is the video I just showed you without the predictions. So without any more talking, let me just get into what I need to do. So we can go into that. I've already made, oh, by the way, so you just need a build directory as well. Let me go ahead. You could just run this as well, just to test if everything's working, and you can see everything does work. So just go back into here. Let's open our main file up, and let's put in our imports. So we'll just do the standard imports: IO stream, memory, and everything that's needed. So now we need a couple OpenCV imports. I'll just copy those in real quick, but they're very simple. You just need a couple of these imports. So these are all our needed OpenCV imports. Can make that a comment. OpenCV right here. Now let's add in a couple other things. Oh, I forgot to add in one more thing. stdih. Okay, let's add our torch script. And basically is everything that we had before. Now we're going to need a couple defaults. So we need to define basically our video size. So set our height and width. So we have a 720 height. Let's do our width as well, 1280, and then our model takes in the input of a image that's 512 by 512, so we got to define that as well. So yeah, 512. Okay. Now we have a couple functions that we're going to need as well. So we're going to have a function that basically loads the model and another function that makes a prediction. So with the, so let's call these our prototypes. These are prototypes. So we'll have our first function called this frame prediction, and it takes in basically each frame from that video, and then it takes in as well as that model that we need to load. So that's our first function. So basically takes in the frame, outputs our prediction. So then we need another one that loads in that model. So let's do that. And let's type in the string of that. Let's type in that model name. So these are the two functions that we're going to need. So now let's get into the OpenCV part. So let's make our main functions. Let's set our variables. So we'll set the torch module right here. This variable is responsible for loading our model. This module, and then our OpenCV variables. This is basically responsible for either opening a video or opening a webcam or camera. We need something to hold our frames, and then again we'll just open up that video that we had saved in our video directory. And then we'll check if we're able to open it. We'll get an error back. Open video. New line at the end. We'll type this out, and this is just a way to close the video. We just enter this out, press spacebar to terminate, and then we'll try to load our model in. Again, try module is equal load model. The name of our model is called traced lanesnet.pt. We can't load it. Just write in this. Oops. For some reason, if we can't load it, get an error back. Saying the model did not load. Okay, so before I continue, let's actually write this load module function, so we can do that right now. Let's copy this. Oops. And let's actually write this function. So this is pretty simple, straightforward. It's very similar to the last video that I did, so I'll just follow that. So we'll just make a string, call our directory. We'll add these two strings together, whatever that model name is, and then we'll load it. And then we'll set this to our GPU. And then we'll just print out our model has been loaded. Oh, we need to set this to evaluation mode as well, my bad. and then we'll just print out model loaded, and then we'll return this module. Okay, so now we'll be able to load in the model and do everything that we need to do. We could test this real quick as well. Looks like we have an error somewhere. 1 second. Making sure all our imports are here that we need. I believe they are. Okay, so it built, and if I run it, it's going to say models have been loaded. So okay, obviously everything's messed up, but it says model loaded, so we can load our model in now. Get rid of this jump. So all I did was basically, I think I forgot something in here, but you can just rewrite this. So now we can load our model in and do everything that's needed. Let's go on to basically the hard part, which is basically making the prediction. So first we need to actually run this for loop. It's actually loading everything in. We'll make this infinite, and basically what we do, we'll read the frame, then we'll check if the frame is empty. Okay, we'll give out an error called blank frame. Saying we got a break frame. So then from there, we'll basically just display the video. So we'll just call this video and display the frame. And then what we'll do, we'll destroy it on, we'll destroy the whole OpenCV window if we press the space bar. So let's test that out. So show the video, and then if we press the space bar, we'll basically destroy the window. So we can do that right here. And then after I do this, we can go into how to create, basically, going into that prediction part. So let's make sure this runs and loads our video out. And it does. It's right here. This will slow down once the model's prediction and everything. There's a way to optimize a model, but for now this is what we have. So let's delete this. Okay, so before we display the video, we want to change that frame. So let's change that frame. And obviously, as I said before, we're returning a prediction. So we're passing that model. Okay, so we'll grab this function right here. and we'll continue. So first things first, let's create our variables. So this is basically going to put a filter that overlays both the original image and the basically the segmentation. So this is determines how much of that filter that we want put on there. The same thing with this variable as well. We're going to need to have two other matrices. So for both of those, for some frames, so we'll have a copy of the original frame and another one as well for our output. We need an input for our model, so we can go ahead and do that now. And then we need to actually normalize the model as well, because these inputs have to be normalized before we can actually do a forward pass or anything. So, or else we're just gonna get some jagged, bad output of our for our image. So let's make our mean and standard deviation. Actually, I don't want to mess this up as well, so let me just copy this. So also, this is just for future advice. Whatever you set your mean and standard deviation in Python with Pytorch, it's in reversing here. So this 0.485 would usually go in the front, and this would go in the back. So you would just reverse these in either or. So that's just a helpful tip. Let's actually resize our model. Our frame. So we can run that through the model. So it takes in the frame, outputs the frame, and then we do a CV to resize. And as I mentioned before, we already set that up there. Image size by image size. And we're good here. And let's actually copy that frame. And then let's convert our frame as well. So we've normalized our frame into this float, and then now we can actually turn this into a tensor. So let's do that. I can actually put this in. So needed for overlay, torch, model input, mean and standard deviation, and then we can go into here CV2 to tensor. So let's do that right now. Push this up. Why is it doing that? Okay, so now we can actually convert this to a tensor. So let's do that. We'll call this frame tensor. And then we'll just do this from blob frame.data. We're just basically setting the dimensions of this tensor right here. I've tried this different ways, but for some reason I have to change the order of the dimensions. So what I'll do, because this 1 by 512 by 512 by 3 can't be input into the model, so I have to change that into the correct dimensions. So it has to be tensor.permute. So I have to make this the correct way, so it should be 1 by 3 by 512 by 512. So basically, it takes this 0 position, leave it there, takes this 3 and puts it at the top, and then shift these image sizes to the back. Okay, so now that's done, we can actually normalize this tensor. We're taking that mean and standard deviation that we set, and we're taking that tensor, and now that tensor has been normalized. We can set that tensor to CUDA, and then once that's done, we can actually set it into our input. So getting ready to push this into our model. So we turn our CV2 image into a tensor, a Pytorch tensor. We reshaped it, and then we normalized it, put it onto the GPU, and now it's ready to go into our model. So let's do that right now. So we'll do this. Basically, this sets the default type to the output of whatever comes out of this model. We have to turn this into a tensor, and then we have to detach it. Same thing you would do in the Python version. And then we'll put this back on the CPU. And then let's actually make the output between 0 and 255. Basically just puts this in RGB. So we'll do that right now. We'll change our type, and then we should be good. And then now what we'll do is we'll basically, this is our forward pass. Now we'll work on basically turning our tensor back to CPU2. So what we'll do, create another matrix, output matrix. The size of this matrix as well, we have to set that by image size. Image size. Set the type, the data type. So let's see, 1, and then the data that we're passing in. We want to add some color to this, so we can just, because right now I believe it's grayscaled. So basically we just turned this output matrix from grayscale to RGB. I want to actually apply a color map to this as well. So the input is we'll apply a color map. We'll take in the input of the color map, and we'll output this color map. And again, we'll set it to this color map. You can find a bunch of different ones. There's jet, rainbow, color map, twilight, shifted. There's a bunch of different color maps. You can set it to whatever one you want. You can just look it up. So now we need to overlay our frame, our original frame actually. I can't spell today, huh? Original frame, and our prediction. So our prediction is basically the lanes on the road. So we can do that right now. So we'll use this function called cv add weighted. We're taking that frame copy. We need that alpha variable that we set before. We're taking that output matrix that we had. We're taking that beta, set this to 0.0, and our outputs. So basically, just combines, like I said, combines our prediction with our original frame, and then we need to resize this back to the original. So I believe we had it in like 1280 by 720. So we can just take that our defaults, default width, default height. And then we're just return our output. So overlay, resize, and everything should be straightforward. So let's come back here. We've written this out already. I believe we should be good to go. Again, expect this to be very slow, but let's hope we have no errors, and it should run. And we have an error. Oh, simple. Default height. Where did we go wrong? Oh, I see where we went wrong. This should be parentheses. I believe we should be good to go. Let's try again. Seems like we have a little bit of a problem. CV no matching function. That's interesting. 1 second. Just retype that. Okay, I believe we should be good to go again. It's weird. Unless we have our defaults set wrong. Okay. Looks like that worked. So give it a second. And you can see right now we have our predictions and everything. So 1 second, let me close this down. Again, I mentioned these two variables. You just had to play with alpha. So if I set this to 0.9, let's see how it looks like. And obviously the speed of the video has basically went down slower just because we're doing more calculations on the GPU. And it'll pop up in a second. And you can see that got rid of all of the our predictions. Let's do one more. Set that to 0.1 and see what the model's viewing. And you can see basically this is the lane predictions that's being made. And you can see it's pretty accurate right now. Like I said, there's a way to make this run faster. You can just go on to quantizing the model, and once you quantize the model, it should run faster. Unfortunately, right now I believe on the Pytorch end you can't run a quantized model on the GPU. It has to be on the CPU.